Okay, so in the previous lecture, we talked about prefixes and I told you what the meaning of prefixes was and what each of the prefix actually mean. Now in this lecture, we are gonna see how we can convert a normal number back into a prefix. Okay, we converted a prefix into a normal number. Now we're gonna see how we can convert the prefix, a normal number into prefix. So well, it's actually pretty much the same as the previous knowledge which I gave you. Okay, so basically what, for example, this is our number, okay, 0.001 meters. Okay, this is some measurement that we have made, or okay, yeah, this is some measurement we have made, and now we need to convert this into a prefix form. Okay, we need to make it a bit more easy to handle. Okay, so now what we can do is we need to move this decimal at the end over here. We need to move it to the right hand side. We'll skip 1 0, we'll skip the second 0, and we'll skip the 1 and bring it over here. In doing so, how many digits did we skip? We skipped 1, 2, 3. 3 digits have been skipped. Okay, remember one thing, whenever the decimal moves from left to right, okay, whenever, look at this arrow, whenever the decimal moves from left to right, it always means that you need to write the answer in the form of a negative power, okay? So the 10 that you are going to add to this one, or you're going to multiply to this one, will always have a negative power, okay, whenever the decimal has been shifted from left to right. Now in this case, it has been shifted by 3 digits, so this would become 1 point, right? 1 point. Actually, it's 1. It's just 1 because where point is at the right hand side, it has no value, okay? This is the whole number that we have. Now, it jumped by 3 digits, right? So you're going to multiply this 1 by 10 with the power of 3. But remember, it has moved from left to right. So this 3 would have a negative sign, okay? This is how you convert a normal number into standard form first. This form is known as standard form. Okay, after conversion to standard form, what have we done? Okay, after conversion to standard form, this is going to be 1 raised to the power of minus 3 meters. If you go back to the prefix table, 10 raised to the power of minus 3 is represented by milli, right? This is milli. This is milli. Okay, so 10 raised to the power of minus 3 is represented by milli, so you can replace this 10 raised to the power of minus 3 by a small m. So this becomes 1 millimeters. Okay, so 0.001 meters is actually equal to 1 millimeter. Okay, now similarly we can have a larger number. For example, it's 0.000 and 001. Okay, so now meters is equal to what digit? All right, so now let's try figuring this out. Let's move this decimal so that it comes to the right hand end of the 1. 1, 2, 3, 4, 5, and 6. We've skipped 6 places or 6 digits. So it's going to be 1 multiplied by 10 to the power of 6. But now, if you look at the direction of movement, it's from left to right again. There will be a negative sign right next to the 6. Okay, so it's going to become 1 raised to the power of minus 6 meters. Now, in this one, what is 1 raised to the power of minus 6 meters equal to? Well, 10 raised to the power of minus 6 means micro. Okay, so this is going to be 1 micrometers. Okay, similarly, let's do another example. Point. All right, so this is one number that we have. Let's do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we brought it to the right hand side of the 1. So bringing it to the right hand side, we skipped 9 places. It's going to be 10 raised to the power of 9. Now look at the direction. It's from left to right. Whenever you skip the places from left to right, I told you have to add a negative sign with the power. And this is going to be in meters. 10 raised to the power of minus 9 actually is represented by nano. Okay, it becomes 1 nanometer. Clear? Now let's try some other examples with positive values or positive powers of 10. Okay, I told you when you move the decimal from left to right, the power is going to be negative. What if you move the decimal from right to left? Okay, this, let's take an example, 1 2 3 meters. Okay, this is 1,000 meters. Well, from your okay, this is 1,000 meters. Remember, at the end of any digit, any number, there is always a decimal. Okay, now you need to move this decimal such that it comes right next to this 1, to the right hand side of 1. You're going to move it from right to left, so it's going to be 1 2 3 digits. You need to move it over here, so it's going to become 1 multiplied by 10 to the power of 3 meters. Now look at the direction of movement. You move the decimal from the right hand side to the left hand side. So remember one thing, when you move it from right to left, the power is going to stay positive. Okay, it's not going to change. It's not, you don't need to move it, change it to negative sign. And 10 raised to the power of 3 is actually equal to the prefix kilo. So replace this 10 raised to the power of 3 by kilo. It's going to become 1 kilometers. And 1,000 meters is equal to 1 kilometers. This is what you might have known already from your previous knowledge as well. So this is how you can change it using prefix method. Let's try another example. What if you have 6 zeros next to the 1? In this case, again, at the end of any number, there is a decimal. Move it 1, 2, 3, 4, 5, 6, so that it comes right next to the 1 on the right hand side of the 1. You moved again from right hand side to the left hand side. Okay, movement from right to left. Okay, right, it's right to left. So right to left movement means that the sign is going to stay positive. It will not change. So 1 is going to be multiplied by 10 raised to the power of 6 meters. 10 raised to the power of 6 actually means mega. It's going to be 1 megameter. Okay, and let's do one more example. Okay, 9 zeros with a 1. Again, you've got this decimal in the end. Move it to the right hand side of 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's right over here. It's going to become 1 multiplied by 10 raised to the power of 9 meters. 10 raised to the power of 9 can be replaced by giga. So it's going to be 1 gigameter. Okay. This is how you convert the simple numbers into prefix methods, into prefixes. Now let's do the conversion from one type of prefix to the other. Okay, from prefix to prefix. For example, I'll just give you this example. 1 megameter is equal to how many kilometers? How to do this? Now let's see. This is pretty simple. Before we do this, you guys should know the meaning of mega. Mega means 10 raised to the power of 6. And the meaning of kilo, which means 10 raised to the power of 3. Once you know these, you could just take this number on the left hand side. It's 1 multiplied by 10 raised to the power of 6 meters. This 1 raised to the power of 1 multiplied by 10 raised to the power of 6 can also be written as 1 multiplied by 10 multiplied by 10 raised to the power of 3 times 10 raised to the power of 3 meters. Why can I do that? Well, that's a rule of indices. Whenever the bases are the same, which in this case are the tens, the powers, they'll get added. When you multiply these two tens, they'll give you 10 raised to the power of 6, because whenever the bases are the same, so in the answer you keep the base the same, but you add the powers, right? It's going to become 10 raised to the power of 6. So this is what I've done over here. I've just split it, the 10 raised to the power of 3 into 10 cube and 10 cube, because I want to convert it into kilometers. Now once we do this, you know that this 10 raised to the power of 3 is actually the same thing as kilo, right? So instead of writing 10 raised to the power of 3, you can write a km. You can write a k. Okay, you just replace the 10 raised to the power of 3 by the k and leave everything as the same. All right. Now 1 multiplied by 10 cube, what does this mean? This means that you've got 3 zeros next to the 1, right? This means 1,000 kilometers. So in other words, I can say that 1 megameter is equal to 1,000 kilometers. Okay. Let's do another example. What if I have one? Okay, this time let's try another, a much bigger number, 1 gigameters, and I need to convert it into let's say again kilometers. So how to do that? Let's see. So for this, you need to know the meaning of giga, which means 10 raised to the power of, sorry about that, 10 raised to the power of 9. You need to know the meaning of kilo, which means 10 raised to the power of 3. All right. Now, instead of writing the giga, I can write it as 1 raised to the power of 9. I can replace it with 1 raised to the power of 9 meters. Okay. Now I need to split this 10 raised to the power of 9 so that I can get a 10 cube. Okay. This 10 raised to the power of 9, just separate the 10 cube from it. After separating the 10 cube, what are we left with over here? You're going to just subtract the 3 from the 9 and you're left with a 6, right? You're left with a 6, 10 to the power of 6, and the 1 stays as it is. Okay? Now this 10 cube is actually the same thing as kilo. Just replace it by kilo and it becomes 1 multiplied by 10 to the power of 6 kilometers. And by the way, you don't need to convert it into zeros. You can leave it over here in this form, okay? 1.0, 10 raised to the power of 6. Okay, why have I placed a 0 over here? Well, I've given this answer to 2 significant figures, okay? Why have I given this to 2 significant figures? Well, usually the examiner asks you to give the answers to 2 to 3 significant figures, so that's why I've given it to 2 significant figures, because you guys might be knowing this from your previous knowledge of math, that whenever a 0 is written after the decimal, it's significant, okay? You can write it as 1.0, 10 raised to the power of 6 kilometers. So 1 gigameters actually means 10 raised to the power of 6 kilometers. Okay. Well, okay, let's try one more example for positive numbers. What if I were to convert gigameters? Oops, guys, make sure you write the meter sign as a lowercase number, okay? Because this is, okay, make sure that you write this meter as a lowercase number, because this meter is actually always written as a lowercase number, okay? So, all right, now 1 gigameter is how many megameters? Let's do that. Right, so you need to know again the meaning of both of them. Giga means 9 and mega means 10 raised to the power of 6. And now let's do this. All right, instead of writing giga, you can write 10 raised to the power of 9 meters. Okay, now separate this into 10 raised to the power of 6. Okay, well, just add in the 10 raised to the power of 6 over here. What are we left with? Just subtract the 6 from the 9. We are left with 3, right? And times 1 meters. The 10 raised to the power of 6 can be replaced by mega. 10 raised to the power of 3 stays at its point. It's going to be 1.0 raised 10 to the power of 3 megameters. Okay, again, I've given the answer to 2 significant figures. 1 gigameters is 10 raised to the power of 3 megameters. And by the way, it's actually quite easy. There is a shortcut to it. Just if you look at the difference in between them, what's the difference in between them? Difference is 3, right? You'll have a megameter which has a power of 3. It's that simple. But this is only applicable when you are going from a bigger value to a smaller value. What if you are going from a smaller to a bigger value? In that case, what would happen? All these examples that I've given you, they are all from bigger to smaller values, okay? Mega is bigger than kilo. Giga is bigger than kilo. Giga is also bigger than mega. What happens if you are going from smaller value to a larger value? Well, that's something that I'm going to discuss in the next lecture. Thank you, guys.